Hello grade 6, how are you today? I hope you are fine. In the beginning, look at the following triangle. This triangle is called Pascal is triangle. And if we look at this triangle, we find that each row starts and begins with 1. Each row starts and begins with 1. And if we look from the third row, we have each number represents the sum of two numbers on the top of it. Each number represents the sum of two numbers on top of it. So 2 represents the sum of 1 plus 1, and 3, 1 plus 2, and 3, 2 plus 1, and 4, 1 plus 3. And each row, the sum of each row equals the sum of row number 1 equals 2 to the power of 0, and the row number 2, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, 2 to the power of 5, and 2 to the power of 6, and 2 to the power of 7, and so on. So from our study to Pascal's triangle, we find out some numerical patterns, and we study today numerical patterns. So what is the meaning of numerical patterns? Numerical patterns is a sequence of numbers according to a particular rule. Is a sequence of numbers according to a particular rule. And this particular rule is increasing or decreasing. This particular rule is increasing or decreasing. So let's take example. If we have the odd numbers, the odd numbers equals 1 and 3 and 5 and 7 and 9 and so on. So we have in this sequence numerical pattern, and this rule is increasing by 2. So we have 1, then we have 3. So number 3 is 1 plus 2. So each number is more than its predecessor by 2. So each number is more than predecessor by 2. So from 1 to 3 we add 2, and from 3 to 5 we add 2, and from 5 to 7 we add 2, and so on. So the particular rule here is to add 2, or as each number is more than its predecessor by 2. If we have the even numbers, the even numbers equals 0, 2, 4, 6, 8, and so on. So we have here a numerical pattern. In this sequence we have a numerical patterns, and its rule is from 0 to 2 we add 2. So, and from 2 to 4 we add 2. So each number is more than its predecessor by 2. Each number is more than its predecessor by 2. So after 8 equals 10, and after 10 equals 12, and so on. Now let's try to solve these examples. Example number 1. Complete the following table. We have in this table the numerical pattern and description of the pattern. We have the numerical pattern 3, 7, 11, 15, 19, 23, and so on, and we need to find out the description of these patterns. We have 3, then we have 7, so we add 4. And from 7 to 11 we add 4. So This pattern is increasing. We have 3, then we have 7, then we have 11. So this pattern is increasing and increasing by 4. So description of this pattern is each number is more than its predecessor by 4. So description of this pattern is each number is more than its predecessor by 4. And we have here space and description of the pattern. Each number is more than its predecessor by 5. So we need a numerical pattern that a number is more than its predecessor by 5. If we say that we have 1, so the next number will be 6, because each number is more than its predecessor by 5. So 6 is more than 1 by 5. So we have 1, 6, and 11, and 16, and 21, and so on. Notice that if the pattern is increasing, the points lies in the end of the sequence. The points lies in the end of the sequence. And if the pattern is decreasing, so the points lies in the beginning of the sequence. Notice that we have here 4 over 4 and 3 over 4 and 1 over 2 and 1 over 4. And we need the description of this pattern. We have 4 over 4. Then we have 3 over 4. So we subtract 1 over 4. We subtract 1 over 4. And we have 3 over 4. Then we have 1 over 2. We also subtract 1 over 4. How? 3 over 4 minus 1 over 4 equals 2 over 4. And 2 over 4 equals 1 over 2. So this pattern, the description of this pattern is each number is less than its predecessor by 1 over 4. And now we have space, and the description of the pattern is each number is less than its predecessor by 4. So we have less than, so we need a numerical pattern, so we need decreasing numerical pattern, decreasing numerical pattern. So decreasing numerical pattern start with points. Decreasing numerical pattern start with points. Then, for example, if we have 18, so the next number would be 14, because 18 minus 4 equals 14. So 14 is less than 18 by 4. 14 is less than 18 by 4. So we have 18, then we have 14, then 10, then we have 6, then we have 2. So we have the numerical pattern is point, then 18, 14, 10, 6, and 2. And we have here 3, then we have 9, 27, 81, and so on. And we need the description of this pattern. So let's find out how to get the description of this pattern. We have 3, then we have 9. We have 3, then we have 9. So we're supposed to say that we add 6, but no. We have 3, then we have 9. If we add 6, then the third number would be 15, and here we have 27. So now if we multiply 3 by 3, then the next number will be 9. And if we multiply 9 by 3, then 9 by 3 equals 27. So the number 9 is a triple of 3. It's triple of 3. And 27 is triple of 9. And 81 is triple of 27. So the description of this pattern is each number is triple of its predecessor. So the description of this pattern is each number is triple of its predecessor. Is triple of its predecessor. So if we have 3 times 3 equals 9. So we say that 9 is triple of 3. Number 2, complete the following numerical patterns by writing 3 consecutive numbers. So we have letter A, 6, 14, 22, 30, 38. Then we have space, space, space. So we need to find out the description of these numerical patterns. We have 6, then we have 14. So we add 8. So 6 plus 8 equals 14, and 14 plus 8 equals 22. So 14 plus 8 equals 22, and 22 plus 8 equals 30, and 30 plus 8 equals 38. So 14 is more than 6 by 8. 14 is more than 6 by 8. So we have here after 38, 38 plus 8. 38 plus 8 equals 46. And 46 plus 8 equals 54. And 54 plus 8 equals, now think, for 54 plus 8 equals 62. Now letter P. We have 1 over 2, 1 over 4, 1 over 8, 1 over 16. So what is the particular rule here? What is the particular rule here? We have 1 over 2, then we have 1 over 4. Yes, if we multiply 1 over 2 times 1 over 2 equals 1 over 4. If we multiply 1 over 2 times 1 over 2 equals 1 over 4. And if we multiply 1 over 4 times 1 over 2 equals 1 over 8. So the particular rule here is to multiply the number by 1 over 2. So we should multiply 1 over 16 times 1 over 2. 1 over 16 times 1 over 2 equals times 1 over 2 equals 1 over 32. So we multiply 1 over 16 times 1 over 2 equals 1 over 32. And 1 over 52 times 1 over 2 equals 1 over 64. And 1 over 64 times 1 over 2 equals 1 over 128. So we have the numerical pattern as 1 over 2, 1 over 4, 1 over 8, 1 over 16, 1 over 32, 1 over 64, and 1 over 128. Now, letter C. We have 2, 3, 5, 8, 12, then space, space, space. So we need to find out the particular rule here. Now think and try to solve this. We have 2, then we have 3. So we add 1. If we add 1 to the number 2 equals 3. So we add here 1. And from 3 to 5, if we add 2, the number would be 5. 3 plus 2 equals 5. And if we add here 3, if we add 3, 5 plus 3 equals 8. And here if we add 4, 8 plus 4 equals 12. So the particular rule here, we add 1. In the first we add 1. So after that we add 2. And after that we add 3. And add 4. And we're supposed to be add 5. We're supposed to be add 5. So first space here equals 12 plus 5. 12 plus 5. 12 plus 5 equals 17. And 17 plus 5 or 6? 17 plus 5 or 6? 6. 17 plus 6 equals 23. Equals 23. And 23 plus what? 23 plus 7. 23 plus 7 equals 30. So the numerical pattern is here 2, 3, 5, 8, 12, 17, 23, 30. 23, 30. Letter D, we have 1, then we have 4, then we have 9. So we add 3 to number 1. 1 plus 3 equals 4. And we add from 4 to 9, we add 5. And from 9 to 16 we add 7. And from 16 to 25 we add 9. We add 9. So we have here 1. From the first number we add 3, then we add 5, then we add 7, then we add 9. So the next we add what? The next we add 11. So 25 plus 11 equals 36. And we add here what? We add 11 to 25. So we add what to 36? We add 13. So we have here 49. And here we add what? We add 15. So the next number is, so we have here 65. So the numerical pattern is 1, 4, 9, 16, 25, 36, 49, 65. Number 3, discover the rule of the numerical pattern and write the missing numbers in each case. So we have letter A, 4, 7, and 30, and 16. First, we look for 2 consecutive numbers. For example, we have 4 and 7. And look for another 2 consecutive numbers. We have 13 and 16. So we look for 2 consecutive numbers, 4 and 7, and another consecutive numbers, 13, 16. We have here 4, then we have 7, so we add 3. And here we have 13, then we have 16, so we add 3. So the particular rule here is to add 3. We have 4 plus 3 equals 7, and 7 plus 3. 7 plus 3 equals 10. And 10 plus 3 equals 13. And 13 plus 3 equals 16. And 16 plus 3 equals 19. And 19 plus 3 equals 22. Letter P. We have 7, but we don't have the next number. And we have here 15, then we have 19, and we have 19, then we have 23. So the first consecutive numbers is 15 and 19. And another consecutive numbers is 19, then we have 23. So we need to find out the particular rule here from 15 to 19 and from 19 to 23. We have 15, then we have 19, so we add 4. And we have 19, then we have 23, so we add 4. So the particular rule here is to add 4. So 7 plus 4 equals 11. And 11 plus 4 equals 15. And 15 plus 4 equals 19. And 19 plus 4 equals 23. And we have 23. 23 plus 4 equals 27. And 27 plus 4 equals 31. Letter C. We have 0.5, then we have 1. So the first two consecutive numbers is 0.5, then 1. And the another two consecutive numbers is 2, then we have 2.5. So we have 0.5, then we have 1. So we add 0.5. And here we have 2, then we have 2.5, so we add 0.5. So the particular rule here is to add 0.5. 0.5 plus 0.5 equals 1. And 1 plus 0.5 equals 1.5. And 1.5 plus 0.5 equals 2. And 2 plus 0.5 equals 2.5, and 2.5 plus 0.5 equals 3, and 3 plus 0.5 equals 3.5. Letter D. We have 128, then we have 64, and we have 16, then we have 8. We have 128, then we have 64. So, can anyone help me to find out the particular rule here? 128, then we have 64. Yes, if we divide 128 by 2 equals 64. So, we divide 128 by 2, then the next number would be 64. And here, from 16 to 8, if we divide by 2, then the next number would be 8. 16 divided by 2 equals 8. So we have here 64. 64 divided by 2 equals 32. And 32 divided by 2 equals 60. And 16 divided by 2 equals 8. And 8 divided by 2 equals 4. And 4 divided by 2 equals 2. Letter E. Space, then we have 15, 12, 9. So we have here two consecutive numbers, 15 and 12. And we have 12, then we have 9. So we have two consecutive numbers and another two consecutive numbers. We have 15, then we have 12. So 15 minus 3 equals 12. And we have 12, then we have 9. So 12 minus 3. 12 minus 3 equals 9. So we need the first number. What minus 3 equals 15? What minus 3 equals 15? 18. Excellent. 18 minus 3 equals 15. 15 minus 3 equals 12. 12 minus 3 equals 9. 9 minus 3 equals 6. 6 minus 3 equals 3. Example number 4. An Egyptian land company reclaims 6 fiddles per day to become prepared and ready for agriculture. How many days do the company require to reclaim about 15 fiddles? Write the numerical pattern which express this and describe it. Focus with me. An Egyptian land company reclaims 6 fiddles per day. So, reclaims 6 fiddles per day. How many days do the company require to reclaim? About 15 fiddles. 15 fiddles. Write the numerical pattern which express this and describe it. So, we have on the first day 6 fiddles. Then, the next day would be 12. Then we have 18. So day number 1 we have 6 fiddles. Day number 2 we have 12. Day number 3 we have 18. If we add 6, 18 plus 6 equals 24. 24 plus 6 equals 30. 30 plus 6 equals 36. 36 plus 6 equals 42. And 42 plus 6 equals 48. So, we say that day number 1 is 6 fiddles. Then the next day would be 12. And the third day would be 18. Because we add 6. 6 plus 6 equals 12. 12 plus 6 equals 18. 18 plus 6 equals 24. 24 plus 6 equals 30. 30 plus 6 equals 36. 36 plus 42. And 42 plus 6 equals 48. So, if we add 6, then we have 54. Then we have 54. So, how many days do the company require to reclaim about 50 fiddles? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So, we have 9 days to reclaim about 50 fiddles. We have 9 days to reclaim about 50 fiddles. So, 9 days. And the numerical pattern is 6, 12, 18, 24, 30, 36, 42, 48, and 54. And the description of this pattern is each number is more than its predecessor by 6.